Hello guys, this is George Bundred from Murray State University, and then I would like to talk with you today about truss analysis using the method of joints. I prepared this as a tutorial since several of you guys are asking questions about the last problem in the homework. So there are two steps to solve these types of problems. The first one is to find the support reactions, and for that we as a first step we treat the whole structure as a single structure, and in that situation you can see that we can use sum of forces and sum of moments around different points, Newton's second laws, to get the support reaction. And probably the easy way for one of the easiest is to get for this if we start for example with the sum of forces around point A, then we get By, and if we are doing then sum of forces around along x direction, we get Ax, and if we do sum of moments around the point B, then we get Ay. So that's how we solve for these three reactions, support reactions. Then the second step is to isolate individual joints and draw free body diagrams for each one of them. And as you can see right now in this second step, the only unknowns are the internal forces in each members. And the convention is to draw them either in tension or in compression if you prefer, but you need to be consistent. Once you start with one of them in tension, then you have to do all of the other ones in tension. So in tension is generally by convention most of the engineers are using it. So as we draw them here, you can see that we can write sum of forces along x direction or y direction, I mean Newton's second law. And for example, if we start at point B in this situation and we write sum of forces along y direction, we quickly see that we are able to get only FBC because FAB acts along x direction. So that then we after we get FBC, then we are able to get sum of forces along x direction. That results in finding FAB. After we find FAB, suppose if FAB assume that we find it is negative, then we have to change it from tension into compression. That means we delete this arrow and we put it here. And then of course we have to change direction here also for this vector right there. So when we are doing that, then we are able to write sum of forces on point A for that joint, and you can see that if we do this along x direction, we get FAB. If we do, maybe this was even easier to start with from the beginning, and writing sum of forces along y direction, you can get FAC. So very simple technique. And then once we find the internal loadings for each of the members, then we are able to calculate the stresses, the average stress for each of the member. It could be either in tension or in compression. I hope this explanation helps, and you can see how simple the technique is, and the problem is not complicated even if it looks like initially. I thank you for your attention and have a beautiful night.